The first video in this series looks at how deep learning is being used by industry sectors to improve outcomes and deliver competitive advantage. With adoption increasing all the time, this second of 6 videos will take you through the principles, terminology and processes of deep learning and AI to help provide a clearer understanding of these technologies and what drives them. AI is the umbrella term for the designing of systems to mimic human intelligence. It's broken down into 2 further subsets. Firstly, machine learning, where the goal is to create a simulation of human learning so that an application can adapt to uncertain or unexpected conditions. To perform this task, machine learning relies on algorithms to analyze huge data sets and perform predictive analytics far faster than any human can. The second subset is deep learning, where in contrast to machine learning, data is processed using computing units called neurons, arranged into ordered sections called layers. This formation is called a neural network, and it's intended to mimic how the human brain learns. Unlike machine learning algorithms, whose performance plateaus with scale and volume of data, larger neural networks with greater quantities of data see their performance continue to increase. This is because the computer uses many multitudes of layers or convolutions to solve the problem one small step at a time. This is referred to as a convolutional neural network, or a CNN. The CNN works because each artificial neuron is connected to only a small window of the previous layer. For example, in a visual task where an image is the input at layer 0, each neuron in the first convolution layer, L1, will only see a small part of the image, maybe only a few pixels. This convolution layer consists of multiple maps, each searching for a different feature, such as lines, edges and gradients in different orientations. The next layer, L2, will then focus in on a subset of these attributes in more detail. The following layer, L3, focuses in again, this time finding combinations of the features of the previous layer, such as lines, corners or curves. Once this process has occurred multiple times, fully connected layers look at the complete output of the previous layer and identify the major features together to give a final result or classification. Alternatively, a recurrent neural network, or RNN, can be employed. This works in the same way as a CNN, but adds a built-in feedback loop where the output from one layer is fed back into the layer preceding it. This enables them to have an internal memory where they're able to remember the input received, facilitating their accuracy in predicting the next event. RNNs are designed to recognize patterns in a sequence of data, such as text, genomes, handwriting, or spoken words. As with most neural networks, the parameters or weights of the system start out randomly and the network will perform poorly. However, during training, you can program the network with what the correct classification of an image is, and over many iterations, the network parameters, weights, and bias are slowly modified to give the correct classification. So now we've covered what deep learning is, why not watch the next video in this series, What Makes Deep Learning Work?